Hello everyone and welcome to this video on how to do a principal component analysis here in Jamovi. So here we have 6 different variables: ID, height, weight, math score, reading score, and science score. Let's see if principal component analysis can explain the common underlying dimension between these variables. To perform a principal component analysis, let's go to Factor and then select Principal Component Analysis. Let's select all of these variables and then drag them into the Variables field. Now let's go down to Component Summary, check Component Summary, Initial Eigenvalues, and Scree plot. So here we can see that all variables load strongly on the first component, indicating they share a common underlying dimension. And the uniqueness values are all low, less than 0.07, which suggests that nearly all the variance in each variable is explained by this first component. If we look at the component statistics, we see that the SS loadings indicate that the first component explains the equivalent of 4.87 variables, and that this first component explains around 97.5% of the variance. This is extremely high, and this is also indicated by the eigenvalues. So here we can see that the first component has an eigenvalue of 4.8, and the rest of them are actually close to 0, which indicates that only the first component is of importance. And we can see that here from the Scree plot with the data indicating that only the first component explains much of the variance. And for this reason, we can go back into the settings of the PCA and remove the rotation, since we only have one component and it does not affect our analysis. And here we've selected the number of components to be based on parallel analysis. This means that the number of components are generated by comparing the data's eigenvalues to those from randomly generated data. This is more statistically robust and accurate than having the eigenvalue greater than 1 rule. And that's how we perform PCA here in Jamovi.